Okay, this is going to be my tip of the day video, and we're going to talk about powering your project with batteries. Now you can see on my breadboard I have a LoRa radio and a microcontroller, so I want to be able to put this out in the field, so I want to power it by batteries. Now there's many ways to do it. You probably have your own way, but this is the way I do it. So the first thing you do, you find yourself a battery, and everybody goes for the 18650 Lithium Ion. This is a 3000 milliamp hour. And it's 3.7 volt lithium ion, so that's a nominal voltage, and the maximum charge voltage on this battery is 4.2 volts. Now this is putting out 3.7 volts, and you can see on the discharge curve it's pretty constant at 3.7 until she drops down to 3 volts. Now my RayX module, my LoRa module, runs on 3.3 volts, and the maximum it can handle is 3.6 volts. You can see that on the data sheet. And the RP2040, which is on this microcontroller board, the maximum voltage is also 3.6 volts. So we have to get some kind of buck boost converter or a buck converter to take this down, to take the 3.7 volt down to 3.3 volts, and we could do that. We could get a buck converter and feed it the voltage of the battery into the buck converter. Then output of 3.3 volts can power our circuit. Okay, I have built many battery-powered projects using the 18650 lithium ion cell, which you can see here. Now I've since stopped doing that. I find that this battery is a little bit too big, physically big, for the enclosures that I want to use for a sensor out in the field. Also, you have to buy a buck converter, and they're usually pretty noisy, the 3.3 volts that's feeding your project. And I've actually seen one of these explode, and it's pretty violent. So if I want to build a project for a friend, I want something a little bit more safe. So I've gone to a different battery, got this battery here. Now this is a lithium iron phosphate battery. You can see it's a 14500 battery. This is a 1000 milliamp hour battery, and a nominal voltage is 3.2 volts. Now the charging voltage on this battery maximum is 3.6 volts. So when you pull this out of the charger, you can plug it into your project. Same size as a AA, so it fits into a battery holder like this pretty easily. And you'll never have a voltage higher than 3.6 volts, the maximum of any of your projects. So it's direct. You just hook this up, it's clean DC power. You just put it into the battery holder and power up your project. Okay, here's a little wireless project that I built in a waterproof enclosure. The lid goes on top like that. So I have a SCAMP3 board, that's a microcontroller, and I have a RayX LoRa radio module, and they run on 3.3 volts, and they're powered by this battery. So this is a lithium iron phosphate battery, so it's hooked directly up to the two devices, so there's no converter board. And if I power it up with a switch, you can see she powers on with the battery. And if I want to do any programming, then I shut off the power, and I could go in with a USB connector, so I could plug that in, and then she'll power up, and now I can do some programming. So the microcontroller can monitor the voltage of the battery. And if you get a voltage divider and divide down the voltage to around 1 volt, then you can use the band gap voltage internally of the microcontroller as the ADC reference, and you can actually tell when the battery needs to be recharged. So all you have to do is just pull out the battery, recharge it, put it back in, and then away you go. Okay, I built a battery charger for my lithium iron phosphate battery, and I mounted it in a battery holder for an AA battery, and it's meant to fit into a Vero board or breadboard. And then I have a charging board right here. It could actually charge up either 18650 or 14500 battery just by changing a jumper on the board. So it's 5 volts input. So here's our 5 volts from our power supply. And if you have a power supply with a current meter, you could actually watch the current come down as it's charging. And then when it's finished, this LED will change, and then you know the battery is charged. Okay, so that was my little tutorial on how to build a battery-powered project. I have a couple of mentions. If you put the battery in the wrong way around, you're going to destroy your project. So you could build a reverse polarity protector circuit, or what I do, I get a battery holder that has 2 wires coming out of it, the black and red, and I put a JST connector on the end. Then on the board I put the mating connector. And I get some heat shrink, and I put it around the battery and the holder, and I heat shrink the battery in so you can't take it out. So to charge the battery, you have to use the JST connector. That way you won't run into that problem. Also, for short circuit protection, you can get onboard fuses that will actually solder onto breadboards or Vero boards. So if there's a short circuit, the fuse will blow for protection.